Hi grade 12s. Now that we've done a brief recap of grade 11 analytical geometry, we can start the really fun stuff, which is the grade 12 stuff. Grade 12 analytical geometry is all about circles, and I really enjoy it. So this topic is just an introduction to circles, and then we'll move on to the more complex questions later. So what I've done in my drawing here is I've drawn what we call the center of the circle. It makes sense that every single circle has to have a center, and our notation is generally A and B. So the x-coordinate of the center is A and the y-coordinate is B. Now basically every single point on the circle, so any point that you find on the circle, this entire circle is made up by infinitely many points, and they will all be the same distance away from the center, and that's the radius, which is r. So I've put a point P there, which is on the circumference. Now that represents any point on the circumference of the circle, and I've said its coordinates are x, y. Now we know that anywhere you are on the circumference, you are r units away from the origin. So what that means is that any point on the circle obeys the same kind of rule. So I've written myself a note there that says exactly that. This circle basically is made up of all the points that satisfy the fact that they are r units away from M. Now the wonderful thing is we have a distance formula. So the distance from M to any point P on the circumference of the circle will be given by the distance formula. Now I know that distance. That distance from the center to P has to be r. And how do we work it out? Well, it's the x value minus the middle, the center's x value squared, plus the y value of the point minus the y value of the center squared. So now I know that the radius of this circle has to always be equal to any point on the circumference minus a squared, plus any point on the circumference is y minus b squared. Now that should be something that is fairly obvious to you, simply because that's the distance formula. Now we don't like square roots, and so in order to move away from a square root, what we're going to do is we're going to square both sides. So I'm going to square r squared, and then I've squared this side, but remember when you square, you cancel out the square root. And so basically, I don't have a square root on the right-hand side, and the left-hand side becomes r squared. And that is the equation for any circle. We actually tend to write it with, let me just change that. We tend to write it with the x minus a squared and the y minus b squared on the left-hand side equals r squared on the right-hand side. That's just generally the kind of way in which we write it. And this is on your formula sheet. So this is the equation of any circle centered at AB. So let me write that in. This is the equation of any circle center AB, and it has a radius of r. So centered at AB with radius r. So very important just to understand, this is my radius, and then A and B represent your circle center, and this is my center. X and y are obviously any point, so this x and y represent any point on your circle. So your equation will always have an x and a y in it because they represent a point on the circle. So let's actually just look at some equations and figure out what the equation tells us. So if I look at these first examples, it says determine the center and the radius of the circle. And you'll notice this is in exactly the right format. This is x minus a, and this is going to be squared, and this is y minus b squared, and this is r squared. So I can see that my center is going to be when x is 1. Now just remember that this minus is in the formula, so the a value is 1. Now if I look at the second part, careful, there isn't a minus here. Now the formula needs to have a minus in it. You have to have y minus and then b. So this b value is going to have to be negative 5, so that the minus and the minus make a plus. So actually the circle center is at 1, but negative 5. Now basically what it means is that the center of the circle has signs opposite to what's in their equation. So you'll see there was a minus 1 for x, and it's plus 1 for the center. There was a plus 5, so it's minus 5 for the center. But it basically comes from the fact that there has to be a minus as part of the question. Now my radius squared is equal to 12, because that's exactly what that has on that side, is equal to 12. So my radius would be the root of that. So either you write root 12. We generally don't write it to decimal places because then it becomes inaccurate, but we prefer to write that in simplest third form. So you just use your calculator and it's 2 root 3. Now you don't have to worry about negative roots because the radius is a distance, and so it's always positive. Right, moving on to the next one. This is a pretty cool one. So you see x squared plus y squared. Now, in order to be able to see the center, you need to see x minus a squared and y minus b squared. Now you'll notice there is nothing that you're minusing. So this means that your center is at 0, 0. Because basically, this is the same as x minus 0 squared and y minus 0 squared. So I've just written myself a note there that says basically I can now assume from now on that circles centered at the origin would have an equation x squared plus y squared is r squared, because I would have a 0, 0 for a and b. And let's just finish this example. R squared is apparently equal to 25, therefore your radius is 5. Right, moving on. Question C, you'll notice that there's nothing attached to the x. So the center is going to be at 0 something. And again, this is a positive. So this will have to be y minus, and then the center of the circle's y value. So this is going to have to be negative 1 to make the plus 1 work. So my circle center is at 0, negative 1. My radius squared is equal to 50. So I square root. And my calculator tells me in simplest third form, it's 5 root 2. Great, so these examples were simply, if I give you an equation of a circle, can you see where the radius comes from, and can you find the radius, and can you write down the center of the circle? So obviously the next kind of skill we need is, if I give you a center and I give you another piece of information, can you write down the equation? So this question says, determine the equation of the following circles, a circle centered at negative 2, 1. So immediately I know it's x minus 2. Now actually, we often just skip that step and write x plus 2 squared. So you don't actually have to show me that reasoning. That's squared. And the next will be y minus 1 squared. Now that equals to, now just be careful, my radius is 4. So this doesn't equal 4, it equals 4 squared. Because your circle, its basic equation has r squared there. So basically this simplifies down to 16. Now there's no reason to show any work in there. So you can literally just write down that answer, and that's absolutely fine. Right, on to the next one. Centered at the origin. So technically this means x minus 0 squared and y minus 0 squared. But hopefully when we're really good at circles, we just know that that's x squared plus y squared. And this will be equal to root 10 squared. And root 10 squared, the root and the squared cancel out, and I get 10. Again, please go straight to the answer. It's no problem. Okay, so then we get our first interesting one. So a circle centered at 0, 0. So we've now gotten into the habits of its x squared plus y squared, as in there's no a and b. Now, this time it doesn't tell us what r squared is. It tells us that it passes through a point. Now, that's not a problem, because the moment you have a point, you can sub into the equation. So in this case, I can sub in negative 2 1s. This is negative 2 squared plus 1 squared. Now that's going to equal r squared. So this is going to be equal to 5 is r squared. Now absolutely I can go and find r, but do I need to find r? My equation is x squared plus y squared equals r squared. So notice there's no point in finding r here. I'm simply going to go and square it. So of course you can find it, but in an exam where we can save time, we should. So here there was no point in finding r, because you are simply going to square it again in the formula. And so where you can cut corners, do it. Going to square it again. Right, so on to another one. Similar to that, a circle centered at negative 2 and 3. So hopefully we start getting used to the fact that this is x minus 2, which becomes x plus 2. And then it'll be y minus 3 squared, and this equals to r squared. Now I have a point on the circle. So once again, I'm going to substitute in 0 and 7. And again, I'm going to solve for r squared, but I'm not actually going to find r because there is no point. So I get 20 on the left-hand side, so r squared is 20. And therefore, I can go straight back to say x plus 2 squared plus y minus 3 squared equals r squared, which in this case is 20. Great, so that example now shows us how we can find the equation of a circle because we're given the center and then sometimes we're given a point or sometimes we're given r. So our final example of just playing around with this introduction to circles is looking at, if I give you the equation, can you tell me the center and radius, which we have tried before. So why is this different? So let's have a look. Well, this one's fairly easy. We know that x squared plus y squared on its own tells us that it's centered the origin. In this case, I know that r squared is 100 because that's my r squared in my formula, which means r is the root of that, which is 10. So that's really easy. Now this is where it gets more interesting. What happens if it's not written in the format? Remember, the whole aim is to get it into the format x minus a squared plus y minus b squared equals a number, which is r squared. So this is clearly not written like that, which is the first time we've seen it given to us in a different format. And this is where, don't feel sad when I say this, we are going to complete the square. Now, I know when we complete the square in grade 11, everyone hates it and they're like, it's so pointless. And here, for the first time, you're going to see it doing something awesome, and it's actually going to be really easy. So what we're going to do is we're going to look at these two. Where would that have come from? That's going to come from x plus something squared. Now, how do I know it's a plus? Because this is a plus. Now, that comes from, if I want the middle to be 2x, I need to halve that coefficient in order to figure out what number that is. So if I halve 2, positive 2, I'll get positive 1. Now let me just show you why. Reason being is if you have x plus 1 times x plus 1, how do you multiply that out? You would go x times x, which is x squared. You'd go x times 1, which is 1x. Then you'd go 1 times x, which is 1x. And guess what that makes? That makes 2x's. And then you'd go 1 times 1, which is 1. So notice your middle terms are always identical. So you always have two of the same terms adding together to give you that middle term. So that's why I halve that. If I want 2x as my final answer, I halve that because it must have come from two identical terms, and I get 1. Now here's the only problem. By writing it like this, this equals this. Now, what equals this whole thing? Now, the only problem is you just went and added 1 to both sides. So, by rewriting it as this x plus 1 squared, we've effectively added 1 by mistake. So, I've written myself a note there. By rewriting x squared plus 2x as x plus 1 squared, I have gone, and yes, it's equal to x squared plus 2x, but it's also equal to a plus 1. So, we have effectively added 1 to the left-hand side of this equation by mistake. Now, if you add 1 to the left-hand side of the equation, you need to add 1 to the right. So I'm adding that because I have to do the same thing as when I added 1 to the left. So this 1 is getting added to the right-hand side as well. Now, if I look at this, this will come from y. Now, exactly the same logic. If this is minus 6, that would have come from two identical terms being added together. So those two identical terms must have been minus 3 y's. So I'm going to halve the coefficient of y. So you halve, not the y itself, just the coefficient. So halve the coefficient of y, and that goes there. Now, if you go and multiply that out, you will realize that that equals to y squared minus 6y, but plus 9. Now, if you've added 9 to the left-hand side, you have to go and add 9 to the right-hand side. So that's there. This comes from, this is because y minus 3 squared actually equals y squared minus 6y plus 9. So you added 9 to the left-hand side by mistake by rewriting it like that. So you need to add 9 to the right-hand side. So what does this actually become? So therefore we get x plus 1 squared plus y minus 3 squared, and this equals 16. So therefore my center, I can now tell my center because it's written in the right format. My center is -1, careful, not +1, -1, 3, and my radius is 4 because r squared would be 16. So basically we're kind of like mini completing the squares here in order to get it into the right format. Okay, let's try again. Well, question C, interesting. First of all, we've never had an example where you have 3 attached to the x and y. Now, we're not actually allowed that. Remember what our goal is? Our goal is to get x minus a squared plus y minus b squared equals a number. So I can't have 3x squareds and I can't have 3y squareds. So the moment I see this, I'm going to divide every single term by 3, which you are allowed to do in an equation because you're dividing everything by 3. So now I get x squared plus 4x plus y squared plus 2y equals 2/3. It's unfortunate about that fraction, but oh well. So now if I look at these two, x squared plus 4x can come from the fact that it would be x, and we halve the coefficient of x, so this is plus 2. So that would have come from x plus 2 squared. However, if you go and work that out, you get x squared plus 4x plus 4. So on the right-hand side, I need to go and add 4. So if I put my 2/3 in, it's now 2/3 plus 4. Now over here, this would have come from y plus half the coefficient of the y. So this is 1 squared plus, because this is a plus. So now if I multiply that out, that will become y squared plus 2y plus 1. But if you go and add 1 to the left-hand side, you must add 1 to the right-hand side. So I've just gone and written myself a note there about where each of those constants came from. Effectively, by completing the square on the left, I added those constants by mistake, so I must add them to the other side. And so finally, I can rewrite my formula as x plus 2 squared, y plus 1 squared, and that equals 17/3. Bit of a nasty fraction. So therefore, what is my center? Well, my center is at -2, -1, and my radius would be the square root of 17/3. Not a very nice number, no problems with that. Right, let's practice some more. Oh, this one's interesting. X squared, it doesn't have any other partner, so he's just x squared. These two would have come from y. Half the coefficient of y, so it's half of -8 is -4 squared. Now here I'm going to kick over the 4 because I want all constants on this side, so it's 4. But I've also added something by mistake here. Yes, that's y squared minus 8y, but it's also plus 16. So I must add 16 to that side as well, which means I have x squared plus y minus 4 squared equals 20. So now that it's in standard form, I can tell you that the center is at 0, 4, and my radius is the root of 20, which I would rewrite in simplest third form, which is 2√5. Okay, now this last one here of E, there's nothing wrong with this one. It's no more difficult than the others, except constants I like to have on this side. This 2y I don't want. I prefer to kick it over. So I'm just going to do some rearranging to make it easier for myself. So I'm going to write the x squared and the minus 8x first, simply so I can complete the square. Then I'm going to write the y squared plus the 2y together so that I can complete the square. And I'm going to leave the 20 on the other side. So x squared minus 8x can complete the square to x minus 4 squared, but that means that you've effectively added 16 to the right-hand side because you've added -4 squared. This one here, this will come from y plus 1 squared, which means you've effectively added 1 squared to both sides. So I must, to one side, so I must add it to the other side. And so my equation of my circle has been rewritten. Don't forget my 20. So if I neaten that up, it becomes x minus 4 squared, y plus 1 squared, and this equals 37. So therefore I can tell my center of my circle. My center of my circle is at 4, -1, and my radius is the root of 37, which is in simplest third form already. Okay, so basically this video was meant to introduce you to the idea of the equation of the circle and what everything meant. Can you make the equation of a circle, and if I give you the equation, can you work out the center and the radius? Well done, everyone.